Right, let's start this one in the usual way. What do we know? Oh, here it is, staring us in the face. We know about z. Z minus I is 2. So we're starting on the z plane with a circle centred at the point I with radius 2. So that's this circle here. And that is x and that is y, and this is the z plane, and it's going over to the w plane, but we don't know what's going to happen. Find a Cartesian equation of C. Oh, okay. Y, that's C2, boring. Okay, so the centre is at there, so it would be like x squared plus y minus 1 squared equals, what's the radius? 2, 4, there we go. Sketch the curve, blah de blah. Right, now the fun bit. So the transformation is that Q is mapped by T onto R. Oh, hang on. Q? Oh, I think that was just to show that we understood loci. Oh, that's just a loci question. That's got nothing to do with the transformation. Let's ignore that. Right, now we've got our information here. So here's our transformation. Q is mapped by T onto R. Q is mapped by T onto R. R, Q, T. This is the Z plane, x plus iy. This is the W plane, u plus iv. What do I know? What do I know? R lies on the real axis. Okay, let's put you on your real axis. R lies on the real axis. So I've got two ways of describing the real axis, haven't I? I've got V is 0, or I've got the real axis is the perpendicular bisector. Real axis is a perpendicular bisector of I and minus I. Now, I think you've probably seen enough to know that the loci one is going to be nicer here. So, what are we trying to do? Given that R lies on the real axis, show that Q lies on C. What was C? Oh, that circle from before. Okay, but look, the circle was given to us in loci form. And I know we wrote it in Cartesian form, but look, it's in loci form there. So I reckon if we start with this, we're going to pretty easily end up with that. But if you want a super challenge, I'm not going to do it on this video, but if you want to be clever, what was it? X squared plus y minus 1 squared equals 4 or something. If you want to be clever, do it the other way, the Cartesian way. So we know about, we know this, V is 0. So start by writing down W equals, then, which is here. Then sub in x plus iy instead of z. Then rationalise the denominator and tidy it all up and make it say W equals stuff plus I stuff, because the stuff is a U plus I V, and we know that V is 0. So take that V that pops out, set that equal to 0 and fiddle around with it, and you should come up with this. It'll be a good challenge for you, but I'm going to do it this way because I reckon it's going to be much easier. But you should do it. You should do the other way that I just taught you through. Okay, let's sub in W. Z plus I over 3 plus IZ minus I, which I will multiply top and bottom by 3. Oops, that's wrong. I will multiply top and bottom by 3 plus IZ. Like that. So I've got a common denominator equals W, which is Z plus I over 3 plus IZ, plus I 3 plus IZ over 3 plus IZ. Okay, usual trick, denominators are the same, modulus top, modulus bottom, cancel, blah blah. Leaving us with Z plus I minus 3I minus I squared Z equals Z plus I. There's no shame in being slow here, like writing I squared and things and coming back to it. Got to be really careful. Plus I squared Z. Okay, Z plus I minus 3I plus Z. And Z plus I plus, okay, I plus 3I I can do. Minus Z. Okay, that's cancelling that. What else can we do over here? 2Z minus 2I equals modulus of 4I. Oh, it's coming together nicely. Let's pull that 2 out. 2Z minus I equals the modulus of 4I. Well, 4I lives here, and that distance is 4. So modulus of 4I is 4. Modulus of the product is the product of the moduluses, so that gives us a 2 over there. You can divide both sides by 2, z minus I equals 2. Done. But it's not very fun, it was too easy. I think doing it this way would be a lot more satisfying, albeit somewhat difficult. Try it, see how you get on. I'll write down the instructions on a new page so you can pause the video and follow them. Okay, so that's how you would do it. I don't know how disgusting that's going to get, but I think you should give it a go and see how you get on.